began my cycle again. Had to stop for the night. There she stood in the doorway, heard the mission bell. And I was thinking to myself, this could be heaven or this could be hell. Then she lit up a candle, and she showed me the way.
Alright, hi there. Today for Algebra 2, we're going to be looking at Chapter 4-7 on the quadratic formula. Alright, this is the quadratic formula. I listed it right here. You should know this. You should assume you're going to have to memorize it. Alright, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a song on the internet about it. You can go look it up. There's a couple of them, I think. Anyway, it might help you memorize it. One of them is like the Notre Dame Fighting Irish song, the quadratic formula. Anyway, this is the ax squared plus bx plus c is where we get a, b, and c. Okay, so that's part of the quadratic formula as well. Now, when you're doing this, whenever we have quadratic equations, you know, that's like something with an x squared in it and a regular y. You get one of three situations. Either it's a parabola, you know, and the parabola either will come down, and it's all about hitting the x-axis. We spend an awful lot of time finding out where these parabolas hit the x-axis. Sometimes it hits the x-axis in one spot, like this situation right here, in which case you get one solution. It's one real solution. The other situation you have is you get two. It's actually two real solutions. And that's if it hits the x-axis in two spots. And the third situation is where it comes down, or sometimes it might be in a different quadrant there. But it doesn't hit the x-axis at all. So sometimes it could be like this also. You know, just A would be negative in that case if it opens down, okay? But that's the three cases, and that's it. It's either one real solution, two real solutions, or no real solutions, all right? And you're going to come across all three of those kind of scenarios in this section, okay? Now, the b squared minus 4ac is called the discriminant, all right? You don't have to know that, but you need to know how to use it. So if I look at the discriminant and I plug in a, b, and c, you get one of three situations. Either it's greater than 0, in which case there's two real solutions. Sometimes it's equal to 0, in which case you get one real solution. And the third situation would be is if it's less than 0, then you get no real solutions. You know, if it's less than 0, then you got a negative number under the radical. All right, so you won't have any real solutions in that case. All right, so that was the basic note-taking part. So I'm going to do the first problem right up here. Solve this using, and I think the directions for all of these, except for maybe one, are the same. Solve it using quadratic formula. Minus 5x. So the first thing you want to do is bring everything to one side. To one side of the equal sign, all right? You want to have equals 0, in other words. So the first thing I'm doing is I'm adding 6, okay? Otherwise, I've got my C will be wrong in A, B, and C. Okay, now I go A equals, B equals, C equals. A is what's in front of the x squared, and if there's nothing there, you put a 1. So A is 1, B is negative 5, C is 6, okay? And then I'm going to plug this into the quadratic formula, all right? Negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a is 1, okay? All right, so that's what I get when I plug it in, a, b, and c. Now I'm going to start simplifying. I have a double negative right here, which makes that positive 5. Okay, anytime you have b is negative, it's going to end up being a positive in that negative b position. This one is always going to be positive because it always has parentheses around it, which means when you take it to the second power, it's -5 times -5 or negative whatever times negative whatever. It's going to be positive, all right? This one, I always take a minute and I go looking and see how many negatives I got here. In this case, the only negative I actually have is the subtraction sign. There's no other, but if I had if 6 was negative, for example, then it would be plus whatever you get when you multiply those three things together. In this case, it's just minus. 4 times 1 is 4. 4 times 6 is 24. All over 2 times 1 is 2. This is moving along nicely. Next, I can go 5 plus or minus the square root of 1 over 2. And the square root of 1 is 1. 5 plus or minus 1 over 2. And now I'm going to break up the plus and the minus. So I can go 5 plus 1 over 2. Down here I got 5 minus 1 over 2. 5 plus 1 is 6 over 2, which is 3. 5 minus 1 is 4 over 2, which is 2. So those are my two answers. X equals 3 and 2. Okay, and that is how you do it. Okay. All right. Yep, that's it. Next one. A, B, and C. So A is 6, B is -5, C is -4. Okay, got those from right here, here, and here. I still write down A, B, and C. All right, I make less mistakes when I do it that way. Sooner or later, if I keep going into this equation up here to pull out B, sooner or later I'll pull out a +5 instead of a -5. Is a mistake that I've made so many times that I still just do it this way. So next, -5 plus or minus square root of B squared minus 4 times A times C all over 2 times A. All right, so start cleaning this up. +5 plus or minus -5 squared is +25. 4 times 6 times 4 is 24 times 4. Which is 96. Now once again, take an extra minute, look and make sure how many negatives I got. I got 2 negatives there, 1 subtraction, 1 negative. That makes it a plus, okay? Big difference, otherwise I always get the wrong answer. So that turns out to be 121 when you add those together. 5 plus or minus the square root of 121 over 12. Square root of 121 is 11. Now I'm going to break up the plus, the minus. And I got 5 plus 11 over 12 and 5 minus 11 over 12. So 5 plus 11 is 16 over 12. 5 minus 11 is negative 6 over 12. Now I'm going to reduce those two. Those are both divisible by 4. That gives me 4/3. This one's -1/2. So those are my two answers. X equals 4/3 and -1/2. Okay. Next one. Number 3. Once again, get that 300 on the other side of the equal sign. That's the first thing you do. So I got x squared plus 48x minus 300 equals 0. And now I go A, B, C. A is 1, B is 48, C is -300. Plug them into the quadratic formula. Negative B plus or minus the square root of B squared. Got some big numbers. Minus 4 times A times C is -300 all over 2 times A. Alrighty. -48 plus or minus square root of 48 squared. It's 2304. I got 1 subtraction, 1 negative, that's a plus. 4 times 300 is 1200. It's 3504. So I got negative 48 plus or minus square root of 3504 over 2. Okay, so next, I need to know what the square root of 3504 is. Uh-oh. Pop-ups. All right, so I'm here. Now, it turns out that if you take the square root of 3504, and you punch it in your calculator, you get 59.19459. That decimal just keeps going and going, which means it's a non-perfect square, okay? Now, we can talk about reducing radicals at some point, and I think it comes up in the next section, but, this is a huge number, and, it turns out that 16 goes into it evenly, so you could break that up into 3504 divided by 16. So you could go square root of 16 and the square root of 219. This is like stuff we do in the future here. So square root of 16 is 4 times 200 times the square root of 219. But, I wouldn't have been able to figure that out probably. Well, it would have taken me a lot of time. I could have, but this is what x equals, okay? In other words, I would just tend to leave it like that. As long as you know that's actually two answers. X equals negative 48 plus the square root of 3504 over 2, and x also equals the negative square root of 3504 over 2. I mean, those are your two answers, and I am okay with this. If it says leave as a decimal, then you have to take that 3504 square root of it and punch in the decimal, okay? So it's 59.19. X would equal negative 48 plus 59.19, and x would equal negative 48 minus 59.19 over 2. If they ask for decimal, that's how you would do it. So these would be your two decimals if you did those out. Okay, so those would be your answers, or that, okay? Depending on how the question was phrased. In this case, I would really have just left this up here, the negative 48 plus or minus square root of 3504 over 2, okay? All right, anyway, there we go. So this one, A is 1, B is negative 2, C is 6. Plug these into the quadratic formula, I get negative 2 plus or minus the square root of b squared. It's negative 2 squared minus 4 times A times C all over 2 times A. All right, so I plug all that in, start simplifying. Negative 2 is positive 2. Negative 2 squared is positive 4. There's only one subtraction sign. Minus 24 all over 2. All right, so this one's kind of cool. So x equals 2 plus or minus the square root of negative 20 over 2. So the square root of negative 20, if you punch that in your calculator, you get error, which means this has no real solutions. All right, in upcoming sections, we'll talk about how to do square roots of negative numbers, but for now, because I've got that negative 20 under there, there is no farther that you can go. And you just leave it like that, all right, and say no real solutions, and we'll move on, okay? So the good thing is you're done, you move on to the next problem. All right, so here's the last kind of question I was going to throw at you before the you try, and that's this one. Evaluate the discriminant to determine the number of real solutions. Okay, so this one, I'm actually not going to do the whole thing out. You'll see here, I'm going to go A, B, and C, and I got A is 1, B is -4, and C is 8. So here's where I go B squared minus 4 times A times C. I'm just going to use that part of the quadratic formula, which is called the discriminant. Plug in my numbers, so that's -4 squared minus 4 times A times C, and see what I get, okay? -4 squared is positive 16. 4 times 8 is 32. So I'm getting -16. So since this turned out to be less than 0, you know, you'd get one of those situations where you'd get no real solutions. Notice how the question doesn't ask for what the solutions are, it just says the number of real solutions, okay? That's the difference. Next one, same directions. A is 1, B is -4, C is 4. So B squared minus 4 times A times C. So that's 16 minus 16 is 0. So since it equals 0, I get one real solution. Just like in the directions, if you have questions about that, you should scroll back to the very beginning of the thing. I'm using this part right here, okay? So if you get stuck on that, look back at your notes there, okay? And the last one, before the you try, I got this. A is -1, B is -4, C is 6. So I got negative B squared, negative B plus or minus the square root of B squared. I'm using just B squared minus 4AC. And that's what my problem is. Sorry, I had a momentary lapse. B squared minus 4 times A times C. Okay, so that's 16 minus, oh, but I better be careful because I got a subtraction and a negative, so that's actually going to be a plus. 4 times 6 is 24, which gives me 40, which means this is greater than 0, and I'm going to get 2 real solutions. You try. This is the last problem. I want you to try this using the quadratic formula. I don't want to know how many solutions there are. I want to know what they are. All right, so you're going to have to do the whole thing out. A, B, C, plug it into the quadratic formula, solve it out, okay? And just so you don't drive yourself nuts wondering if you got it right or not, those are the answers. I want to see it done by quadratic formula when you come into class, okay? And that is all I got for tonight. Have a great night. See you all soon. Close it out with a little bit of music.
Hotel California, such a lovely place, such a lovely place, such a lovely face. There's plenty of room at the Hotel California. Any time of year, you can find it here. Her mind is different and twisted. She got the Mercedes Benz. She got a lot of pretty boys that she calls friends. How they dance in the courtyard, sweet summer sweat. Some dance to remember, some dance to forget.